All right. Today we're going to talk about independent events versus dependent events. And when we talk about events, we're talking about outcomes of different events and scenarios that can happen. So we're talking about probability, like how likely is it for certain events to happen. Well, sometimes certain events are independent events and sometimes certain events are dependent events. So let's talk about independent events versus dependent events. Dependent events are events that can affect each other or change the probability of something else happening. Independent events are events that do not affect each other. So events that don't change or affect probability of anything else happening. An example of an independent event would be every time you flip a coin, it's an independent event. Because if you flip heads on your first try, it doesn't really affect whether or not you're going to flip heads the next time. Every time you flip a coin, it's an independent event. Same with rolling dice. What you roll with one die doesn't affect what you roll on the next time you roll a die or on a different die. They're independent of each other. They don't affect each other. But some events do affect each other, and these are called dependent events. So, dependent events would be something like this. If you were going to draw cards out of a deck of cards, you've got 52 possible outcomes. We've talked about this before. There's all these different kinds of cards that you could draw, and there's 52 of them. So each time that you draw a card, that's an event. Now, if you draw one card, what's the probability that that card is the Ace of Hearts? Well, there's only one Ace of Hearts out of 52, so the probability of drawing the Ace of Hearts is you have a 1 in 52 chance. But let's say you drew two cards. That's two events. And the probability that you draw an Ace of Hearts and then on your second card you draw a King of Diamonds would be 1 out of 52 for your first card, but then when you draw your second card, the probability of getting the King of Diamonds isn't 1 out of 52, it's 1 out of 51, because once you drew your first card, the deck doesn't have 52 cards in it anymore. The deck only had 51 cards in it left to draw from. Do you see how what you did on the first event affected the probability of the second event? Because normally when you draw a card out of a deck, you have a 1 in 52 chance. But if you've already drawn one card, the second event is dependent on what happened with the first event. Okay, basically, the idea here is that with dependent events, you're going to still multiply fractions out, but you have to adjust the second fraction because of what happened with the first fraction, because the number of possible outcomes was affected by the first event. If this isn't quite clicking yet, that's okay. Let me try another example. Let's say that there were 9 students, and of the 9 students, 5 of them were girls and 4 of them were boys. And let's say in this group of 9 students, I wanted to make a group of 3. So of the 9 students, I'm going to pick 3 of them to be in a group or work together on some kind of a project. What's the probability that that group would be 3 boys and no girls? Well, when I choose the first person in the group, I had a 4 out of 9 chance of drawing a boy, right? Because there was 9 kids and 4 of them were boys. So I had a 4 in 9 chance of picking a boy. When I draw or pick or choose the second boy, I'm not going to have a 4 in 9 chance anymore. I'm going to have a 3 in 8 chance. Why? Because after I picked the first kid, there's only 8 students left, and 3 of them are boys. So that's how my probability of drawing the second student as a boy is 3 out of 8. Now I'm going to choose one more student. What's the probability that this student is going to be a boy? Well, now I have 7 students left. 2 of them are boys and 5 of them are girls. So I have a 2 in 7 chance of getting a boy on this one. And so the overall probability of choosing 3 boys is going to be 4 ninths times 3, eighths times 2, sevenths. And that's a whole bunch of stuff. But remember, you just have to do top times top times top, bottom times bottom times bottom, and then reduce. And the answer should come out to 1 over 21 once you reduce everything out. If you feel like it, you can pause the video and you can check my math on that to see how 4 times 3 times 2, which is 24, over 9 times 8 times 7, which is some other really big number, reduces to 1 over 21. But hopefully the main idea here is that you saw how each time you made a fraction, you had to adjust that fraction because of what happened in the prior events or in the previous events. This is dependent probability. These are dependent events because what happened the first time affects what happens the second time or the third time, and so on and so forth. So all I would like you to do now is I want you to try this on your own. And you're going to tell me, what's the probability if you were drawing cards out of a deck of getting 2 queens in a row? Remember, these are the cards you have to choose from. So if you drew 2 cards, what's the probability of drawing 2 queens in a row? Try that. See what you get. I'll check your answers tomorrow. Have a nice day.